So we're going to talk about rate of change and the slope. We're going to deal with how the rate of change is the slope. When I say rate of change, I'm talking about how the speed changes. Let's say if we're in a car. If you're driving 60 miles per hour, the rate of change is 60. Because every hour you drive, you go 60 miles. So if you drove 2 hours, how many miles would you go? 120. And if you drove 3 hours? 180. And 3 hours is pretty common in West Texas for being next door. So let's look at this. We've got a table that shows the approximate height of a football after it's kicked. Tell whether the rates of change are constant or they're variable. So if they're constant, that means the rate of change stays the same all the time. It is proportional, meaning that every fraction equals the same thing. Now, tell me, Timothy, I know you're a big football player. When I kick the football, does it go at the same speed the whole time?
No.
And the same height the whole time? No. So what do you think on this table, what is it going to look like? Is the rate of change going to stay the same?
No.
Why?
Because when you kick the ball, it'll go at a certain speed going up, and when going down, it'll go.
Okay, so already we're looking at this table and saying it's not likely, right? So let's find the rate of change. Remember, x is always first, and y is always the second one. So I'm going to label my columns x and y, even if it's not in rows, x and y, which means what I've got here, since I know that k equals y over x, and y is feet. Everyone following?
Yes.
What's x?
X is
Time in seconds, right? So feet per second. That makes sense, doesn't it? Would it make sense to say the football went so many seconds per foot? It sounds silly, doesn't it?
I know.
So it doesn't work. So feet per second, I'm good. So let's find out. At the beginning, it started at 0, 0. Now, if it remains a ratio, that would make this proportional, right? Let's look at here. At 0.5 to 18. So how do we calculate this?
25 times it.
Y over x. So what's y here? 18. And x? 0.5. All right, so everyone get out calculators. What is 18 divided by 0.5? Remember, leave it as a fraction if it gives you a fraction back.
36.
So it's 36. Right? So let's do this next one here. Again, y over x. What's y?
31.
31 over
1.5.
1.5. What's 31 divided by 1.5?
20.6.
What is it?
20.6.
Do 36 and 20.6, are they the same ratio? No. So is this constant or variable? It's variable because it changes. So pretty much anytime you're looking at something like this, you can almost look at the situation and expect it. If that football accelerated at a constant speed, we're talking it's in space. It's the only where that's possible is if you kicked it in outer space, it would go away at the same velocity and the same line and just never stop until it collided with something. Only way it can happen. On a real football field, it starts fast, then it slows down, and it changes height. Right? So let's look at number 2. So that's the first one in that we're trying to decide, is it a constant or isn't a constant? It's variable. Once it's variable, we can say it's not proportional. Bam. So number 2. If you've got a line on a graph like we got here, choose 2 points. And what we want to choose is what's called lattice points. They're called lattice points. So what we're looking for is something called a lattice point. A lattice point is where the line crosses perfectly over 2 grid lines. Does that make sense? What you got?
I got 1, 3.
1, 3. That is a lattice point. So I need 2 points on the slope.
Mine's 6.
Okay, so this one is actually not 1, 3. What is it?
0.5.
0.53. And then 1, 6. All right, so now we're going to find the change, what we call the rise over the run. So we're going to rise first. Always rise first, and I'm going to make a right triangle. How far am I going to rise? I'm going to rise until I reach the horizontal line from the second point. So I rise 1, 2, 3 points. So I rise 3, right? Then I run. Well, how far did I run?
1.
No, look at this graph. It goes from 0.5 to 1. 0.5. So now I'm going to write rise over run. The rise was 3. And the run was 0.5, 0.5. So what's 3 over 0.5?
6.
Don't blurt. Give everyone a chance, okay? I know some of you are getting it. That's great. Give everyone a chance to get along too. Mackenzie, are you using this?
I have a question.
What you got, ma'am?
How is it 0.5? Because you move it over.
It's
Okay,
0.5
look at-
one.
It's a great question. Here's the deal. On all grids, you got to pay attention to what the grid line says. Look here. There's 1 right there, right? And there's 2. So is every grid line equal to 1?
No.
What is between 0 and 1?
0.5.
A half. That's what we wrote, right? I could have written it as 1/2, and that would have been exactly the same thing as 0.5. Do you agree? It's just a choice. So what is 3 divided by 0.5? 6. And one of those things you can do if you feel the urge is put it over 1. Rise over run is a lot easier if it's a fraction. Does that make sense? Rise over run is a lot easier if it's a fraction. If you get decimals, you got to convert them to fractions. That's kind of why we do the flashcards with 0.6 repeating and 0.3 repeating and 0.75. So you start seeing those things. Okay. So finding slope is pretty easy. Rise over run. Let's go to number 3. This graph shows the rate at which water is leaking from a tank. The slope of the line is given the leaking rate in gallons per minute. So again, we've got 2 points just like we did before. What's the first step? Rancy, what's the first step? Rancy? Rise. So I'm going to go up until I find a line that's horizontal with that second dot, and I'm going to stop there. Now, pay attention to the units. What are these units here?
They're ones.
Going up. Are they ones?
They're ones, yes.
So how far did I rise? 1, 2,
4,
3.
3, sorry.
The next one, I'm going to run.
4.
So 1, 2, 3, 4. I look down here. These are all ones. 4. So I rise 3. I run 4. The rate of gallons is rise over run, or 3/4 gallons per minute.
That's all we have to do.
That's it on that one. Now, here's the one thing, and pay attention to this. Negatives. If I have a negative slope, that means it rises to the left, or if you alternately want to say it drops to the right. Does that make sense? Positive slope always rises to the right. Negative slope rises to the left. If I have a negative slope, I'm going to have a negative sign over there. So if I have a fraction, and it's like negative 1/5, what does the negative apply to?
The left.
It applies to the whole number, all of 1/5. Now, here's the easiest way to say that. If you've got a slope and a negative number, think about this. The rise is always going to be the rise. Make the run negative, because instead of going to the right, like you would a positive, your negative number takes you to the left. It's much easier to calculate as a negative run than it is to calculate as a negative rise. Does that make sense?
Yeah.
So if you do that, write it as 1 over negative 5. It'll make the whole process easier for you. All right?
Oh yeah, now we get taken.
Any questions on that?
Nope.
All right, let me stop my recording.